Okay.
So here's what we're going to do. We're going to draw a square, giving the side length any integer value you want. All right. There's a square. And all I need you to do, like it says, is to make the side any length you would like to make. All right, so there's our square. All right, so you make this any side length you want. Odd, even, whatever you want it to be. All right. Now, what are the angles of a square measure? How many degrees? 90 degrees. All right, we're then going to draw a diagonal. Diagonal is a line segment going from one vertex to another that is not a side. Now, in addition to being a right angle, all sides of a square are what? Congruent. So whatever you label that side, please label that other side as well. All right. Now, because that's congruent, all right, that triangle is isosceles. So if this is 90 degrees, these two angles have to be congruent. They have to be 45 degrees each. All right. Whatever number you picked for that, what I would like you to do real quick is find the length of the diagonal. Find the length of the diagonal. Not as a decimal, though, as a simplified radical. As a simplified radical. All right, so let's say we picked 5, and you picked another number, it's 5. All right, by using Pythagorean theorem, 5 squared would equal d squared. 5 squared is 25, 25 plus 25 is 50. D would then be the square root of that. Since 25 goes into 50, I would pull out a 5. I'd be left with a 2. All right? So basically, if I picked 5, the diagonal length would be 5 root 2. Did anybody else have a different number side length? Yeah, what'd you get? Yep, what'd you get for the diagonal? And radical 2. So I got 10 and 10 root 2. Any other numbers we're looking at? 8 and 8 root 2. You see the pattern. So if you picked happy face for your side length, the diagonal length would be happy face root 2. Okay? So if you ever have a square with a side length, its diagonal length is always root 2. Okay? If we flip it over and we want to fill in the notes, that is how we derive what is called a 45, 45, 90 right triangle or an isosceles right triangle. All right? Or an isosceles right triangle. In a 45, 45, 90 triangle, both legs are congruent, the isosceles part. and the length of the hypotenuse is root 2 times the length of the leg. All right? So if they give you the length of the leg, you simply multiply by root 2 to get the diagonal. If they give you the length of the diagonal, you're going to go the opposite direction, so you divide by root 2. All right? Now, a lot of times we'll give you patterns that enable you to do it without doing complicated division. Next week, when we deal with more challenging problems, once we have our footing set, all right, on all this, we'll go through that as well together. All right? And we'll go through practice problems today. Everybody good? Okay, now, here's what we do next. We're going to draw ourselves an equilateral triangle. All right, we're going to draw ourselves an equilateral triangle. All right, now as we know from earlier in the year, 4.5, equilateral triangles are also equal angular. So these all measure 60 degrees. Okay. Now what we're now going to draw in is the height. The height goes from a vertex and is perpendicular to the opposite side. We'll spend more time with that when we deal with area. All right. But remember, if this is perpendicular, all right, that means, all right, those are congruent because that's got to be the midpoint, and it also bisects that angle. So those angles have to be 30 degrees. All right? So what I want you to do is make the side length any even number at all. So make this an even number as long as it's even. And then use that real quick to find the height of that equilateral triangle. So make the side length an even number. That's the only difference between this one and the last one. All right? And then find the height using that information. What? It's online. You can go check it out. Yep. So obviously you're asking what we did. All we did was draw a square. Yeah, that's what you're doing. So we just drew a square. We gave that side length and side length one. I know you're asking what we did. All right. So if I made my side length, let's say 12, we made it an even number. All right. That means since that's a midpoint, x would be 6. And once again, we'd use Pythagorean theorem to get the height. 6 squared plus h squared equals 12 squared. 6 squared is 36. 12 squared is 144. Subtracting the 36, you would get 108. And then when you simplify it, h equals 6 root 3. So my side length was 12. My height length was 6 root 3. Somebody else want to give me their side length? 4. I'm willing to bet my children's, let's say, kidney. Maybe they can survive without one. 2 root 3.
Yeah.
Anybody else want to play the wager game? I can bet my kids' other organs, the ones they don't need. The appendix. Nobody wants to play. Come on, it's Christmas time. What? You already had 4? He stole yours, Steve. Nobody else has it. Okay. Oh, somebody had 10? Perfect. Well, I'm willing to bet the appendix that it would be 5 root 3. All right, do you see the pattern there? Basically, it's not the same number, but the number on the outside is what fraction of the side length? Half. And this time the radicand instead of root 2 is root 3. All right, this is what we call, ladies and gentlemen, a 30, 60, 90 right triangle. All right, so when we go on the back, all right, you do have to make one small correction to a typo. See how it says 30, 30, 60? That should be 30, 60, 90. Sorry about that. The 30, 60, 90 there. It says in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the short or shorter leg, depending upon how you want to describe it. All right. The length of the longer leg is root 3 times the length of the shorter leg. All right. And again, we're going to walk through practice problems, but the idea is this. If they give you the short leg, which is S, the hypotenuse is going to be double that. And the longer leg is going to be the short leg root 3. If they give you the short leg root 3, you drop the root 3 to get your short leg, and then you double that to get your hypotenuse. If they give you the hypotenuse, you cut in half to get your short leg, and you multiply that by root 3. All right, now just making sure you realize if a problem asks you to work with a square, realize its diagonal creates a 45, 45, 90 right triangle. If a problem asks you to work with an equilateral triangle, realize its height creates a 30, 60, 90 triangle. Everybody good with that? So the idea is instead of giving you 2 sides, they're only going to give you 1. And then you're going to use the particular angle to get the side length. Okay? All right? So, we look at the 8.2 practice form K. Okay? They have to give you an angle measure in addition to the 90, the 45. You don't have to draw it in, but that means that other one's 45. It's up to you what you need to do. So the legs are congruent. So if they give you one leg is 20, that means the other leg also has to be 20. And then the hypotenuse would be 20 root 2. Okay? If we look at number 3, now they're giving us the hypotenuse, which is 24 root 2. Well, if we take away the hypotenuse, we just have the number 24, and that's both of your legs. So both of your legs would be 24. All right. Now, when they give you an integer value for the hypotenuse, this is the long way of thinking of it. All right. That is equivalent to x root 2 from the notes you just wrote down. All right. So this is the long way of doing it. You don't have to do it this way. All right. X root 2 equals 16. We want to solve for x. How do you get rid of a multiplication by root 2? Divide by root 2. All right. What are the root 2's going to do to each other? Cancel out. Now you are responsible for rationalizing the denominator. So that means that becomes root 2 over root 2. So this becomes 16 root 2 over 2. And then you are responsible for realizing since 2 goes into 16, that breaks down to 8 root 2. All right. Ladies and gentlemen, what is the relationship between the number on the outside 8 and the original hypotenuse 16? In other words, what fraction of 16 is 8? That will always be the case. If they give you the diagonal, an isosceles right triangle as an integer value, cut it in half and just put root 2 alongside. So if we slide over to number 5, we're looking at 44. What's half of 44? 22. So that means that would be 22 root 2. Okay? So you don't have to go through that if you don't want to. Next week, when there's different radicals, we'll work with it and show you what you do. All right. So if this one's 22 root 2, that means this side's also what? 22 root 2. And just briefly, if they then ask you to get the perimeter, you add up the sides. We can put these together because they're like radicals. So we're going to add those up. 22 plus 22 is 44. The root 2 comes along for the ride plus 44. All right. If you do it correctly, these two numbers should always be exactly the same. All right. Now, if you do area of a triangle, remember, is 1/2, and then the base times the height. So that'd be 22 root 2 times 22 root 2, often known as 22 root 2 squared. Everybody good with that? We haven't talked about area yet. All right. So basically what happens is when I square root, what do they do to each other from the other day? Cancel out, and you're going to be left with just 2. Well, what does 2 and the 1/2 do to each other? Cancel out. So you're left with 22 squared, which would be 484 units squared. All right. Now we got some word problems. An architect is planning a new town square. The square has sides that are 20 feet long. A walkway will also cut diagonally through the square. How long will the walkway be round to the nearest tenth of a foot? All right. So there's my square, town square. And there's the diagonal walkway. It says the square has sides that are 20. All right. So if we remember this correctly, realize it's a square, so this is isosceles right. So that means this diagonal would be 20 root 2. But this problem, not just because it's a word problem, but it also specifically tells you to do what? A round. Root 2 is about 1.4, but it's a little more than that. So you go to your favorite calculator piece, and you do 20 root 2, and you get 28.3. It would be about 28.3 feet. And then next week we'll talk about rounding a decimal into inches. When it wants exact, around to the nearest inch rather than that. Charlene made a square quilt block by piecing together 4 congruent isosceles right triangles. The diagonal of the square is 6 inches. What is the perimeter of the square in simplest radical form? All right. So again, they tell us it's a square where the diagonal is 6. Well, what's half of 6? 3. And then we put alongside it what? Root 2. It's a square. So one side is 3 root 2. That means they're all going to be 3 root 2. So we can simply multiply by what? 4 to get the perimeter of a square. And then we end up with 12 root 2 inches. All right? So make sure you pay attention to the direction. And piggybacking off that, 8. A square has a side length of 11 root 2 meters. What is the length of the diagonal of the square? All right, so the side length's 11 root 2. That means the diagonal would be 11 root 2 times root 2. Because remember, the diagonal is the side length times root 2. Whenever I, again, multiply the same radical by itself, it cancels out to give me 2. 2 times 11 would be 22 meters. All right, number 9 is an example of one where you have to remember the dividing by 2 parts. It says a square has a diagonal of 15 centimeters. What is the length of a side expressed in simplest radical form? Because this is odd, it's going to be very hard for you to find without remembering this. So half of 15 would be 7.5 root 2. Good. Classmate said that the perimeter of an isosceles right triangle can never be a whole number. Is this true? Explain. Yes, it is. Because one side at some point would have to have a what if the other one's were integers? A root, no matter what. All right? Good? All right, so that covers isosceles right. All right, now the back. Now we're dealing with the 30, 60, 90s. All right, so with 30, 60, 90s, your first job is to identify which one they're giving you. They're giving you the hypotenuse, which is 14. Now, if this one's 60, this one's 30. Remember, the shortest side is always opposite the smallest angle. All right, so the smallest side is opposite the 30, always. And the smallest leg is always half the hypotenuse, or the hypotenuse is double it. Either way, we're going to divide by 2. 14 divided by 2 is 7. And then the longer leg is that same 7 root 3. In number 13, they're giving you the short leg. The hypotenuse is double that. Double 15, you get 30. The longer leg is the short leg times root 3. All right. 14. Now they're giving me the longer leg, which is 8 root 3. So I'm going to drop the root 3 to get the short leg, which would be 8. And then the hypotenuse would be double that, which is 16. Good. So the same idea with number 15. Now they're telling you the long leg is 4 root 3. Short leg would be 4. Hypotenuse would be 8. If they ask you to get the perimeter, could you add those two since they're both constants? Yep. You get 12 plus 4 root 3. If they ask you to get the area, we can multiply anything we want. We would multiply 4 times 4 root 3, which would be 16 root 3, and divide that by 2. All right? Work on 16 real quick. The top of a giant slide. Monday. That's due Monday. So this is the homework that corresponds to 8-2. It's due Monday at midnight. I will post the homework solutions to 8-1 and the simplifying radical sheets later today if you want to take a look at that. All right. The distance formula, remember, is due. You're welcome. The distance formula, remember, is due tonight at midnight if you haven't done it already. All right. Short leg is 30. That means the diagonal would be 60. So it's 60 feet down the slide. Good? Okay. Now, the one thing we got to work on is, well, we got to work on a couple things. One in the bottom group and then 17. 17 says the frame for a garage roof is shown at the right. How long is each of the top pieces? Round to the nearest tenth of a foot. Okay, so here's the idea. That's an isosceles triangle, the shape of the roof. So these are congruent. That means that angle is bisected if that's the right angle. What's half of 120? 60. So that's a 30, 60, 90 right triangle. Okay? So if I draw that separately, okay, there's my 60, there's my 30. They're giving me the 6 foot is the x root 3 side. That makes sense? It's the longer leg. So I set x root 3 equal to 6. How do I get rid of a multiplication by root 3? Divide by root 3. Cancels out. I got 6 divided by root 3. If I rationalize the denominator, that means I multiply top and bottom by root 3. All right, that's going to give me 6 root 3 over 3. This 3 go into 6. Yep, twice. So my final answer would be 2 root 3. All right. Now, they want to know how long is each of the top pieces. I would take the 2 root 3, which is the short leg, and multiply that times 2. If I double 2 root 3, I got what? 4 root 3. And since it says round to the nearest tenth of a foot, I'm going to go to my calculator. 4 root 3. And I get approximately 6.9. All right. Now, a couple things about that problem. Number one, remember in the last one we divided by 2? What's the relationship between 2 and 6? Instead of dividing by 2, you're dividing by 3. Make sense? So whenever they give you the root 3 side as an integer, divide by 3 and put root 3 along to it. Second thing is you'll notice I didn't round to the very end. Try not to round until you absolutely have to. Okay? Because you may make a small mistake. In other words, if you round this, root 3 is about 1.7. You round to 1.7 right away, all right, and multiply by 4, you'll get 6.8. So you'll get over the error. All right, just keep that in mind when you're doing this. Okay, now the ones on the bottom. Find the value of each variable if your answer is not an integer. Express it in simplest radical form. Guaranteed you'll have one of these on next week's quiz where they combine the isosceles right and the 30, 60, 90. So you're looking for a side length. So that's 12 root 2. That's the hypotenuse of an isosceles right. So if we drop the root 2, we have the side length, which is A and B, which are both 12. Make sense? Now we take that value and we go to this. That's a 30, 60, 90. Short leg is 12. Hypotenuse is double that. 12 times 2 is 24. And then down here is 12 root 3. Now, what you then would have to do is find the perimeter and area. Remember, with the perimeter, you can only add like radicals. All right? Also, remember, with the perimeter, we do not include the 12, because that's not outside, that's on the inside. I can put together the 12 and 24, though. What's 12 plus 24? 36. Plus 12 root 2 plus 12 root 3. Sometimes you'll see it in a multiple choice question where they factor out the 12, but more on that next week. The area would be the base, 1/2 base times the height. Okay, the base is these two put together. Does that make sense? So that would be 12 plus 12 root 3. And then the height would just be the 12 that's on the inside. Myself, I would do half of the 12 over there. You can multiply in any order you'd like. So what's half of 12? 6. So that becomes 6. And then I would distribute that through, and it becomes 72 plus 72 root 3. And then whatever the units are. All right, so just to make you aware of that. Okay? In 19, they're giving you the 18 root 3 for the hypotenuse. Don't get confused by that. All right? The short leg is what fraction of that? Half. What's half of 18 root 3? 9 root 3. And then the longer leg would be the short leg, which is 9 root 3 times root 3. Well, when I do 9 root 3 times 9 root times root 3, the root 3's cancel out and become 3. And at the end of the day, I got 27. All right? And on the other side, if that leg is 9 root 3, this leg would also be 9 root 3 because it's isosceles, right? And the hypotenuse is that times root 2. So root 3 times root 2 would give me 9 root 6. I'm all said and done. Good? Okay.